to be the best so-called proof that man walked on the moon. Additionally, this spectral data can also be used to cast a doubt on the data from Clementine and Lunar Prospector, which suggested that the entire lunar surface was made of material similar to the Apollo soils, and thus compelled geologists to concede that there is no reason to suspect that rocks different from the Apollo samples would be found at unsampled regions of the moon. I think Randy Korative put it best along these lines.
As noted above, there are known exceptions to the generalizations, and we lunatics surely hope that we haven't discovered all the minerals and rock types that occur on the moon. However, known samples of unusual composition and mineralogy are rare, and usually occur only as small, less than 1 gram, clasts in breccias or in the soil. We have no reason to suspect, based on data obtained from orbit on the Clementine and Lunar Prospector missions, that any region of the moon is rich in types of rocks significantly different from those we know about or postulate might exist. Most ore-forming processes on Earth involve water, so we would not expect any hidden ore deposits on the moon. Keep in mind that if more than 40 lunar meteorites have been blasted off the moon and found on Earth, then at any given point on the lunar surface, there can be rocks from any other point. For this reason, the fact that the lunar surface was poorly sampled by the Apollo and Luna missions is in itself not a good reason to suspect that rocks vastly different from those we have studied exist at unsampled points on the moon. Tens of thousands of lunar rocks and rocklets have been studied since the Apollo missions. It is highly unlikely that any yet unfound lunar meteorite will differ substantially in the minerals it contains or in its geochemical character from the Apollo lunar rocks.
That statement was made before the Smart 1 crashed into the moon and found that the actual lunar mineralogy was different.
It's almost 500,000 kilometres from the moon, but this radio telescope is also very close to the action. 3 years ago, the European Space Agency launched the Smart 1 space probe. Today, it was on a collision course for the moon.
All the other controlled impacts on the moon have generally been either on the far side of the moon where we couldn't see it, or in the polar regions where it wasn't so easy. This is the first time we've had the opportunity to really get a good glimpse of it with all the telescopes that are available.
Observatories in Chile and Narrabri in New South Wales also were trained on the probe. But at 26 metres across, the Mount Pleasant Observatory outside Hobart had the most sensitive equipment to help determine what the moon is made of. Finally, collision time. By punching a 10-metre hole in the moon's surface, the probe has uncovered minerals different to the rocks gathered on the surface during moonwalks. The key is the chemical signatures in the dust and debris thrown up by the collision.
And also the radiation in the infrared can tell us the temperature, which tells us how much energy was released and what the material must be made of.
Today's collision could also unlock the secrets of the moon's origins.
So each theory of moon's formation has a prediction for what the moon should be made out of, and by looking at what the moon is actually made of, we can eliminate some theories and reinforce others.
It's hoped results will be available within a year. Michael Lockerbie, ABC News, Hobart.
Korative's statement was also made before Chang'e 3 found such wacky proportions of the elements within the soil. After my video was published, a certain member of the pro-NASA side wrote in to say that the high titanium that the Chang'e 3 found was expected. As a reference, he cited a Smithsonian article that states that according to the Clementine data, Chang'e 3 was scheduled to land in a very high titanium region of the moon. Just how high is very high titanium? We are not told in the article. Well, according to this Planetary Science Research Discoveries article, the Chang'e 3 landed in a region that according to the Clementine data is only 3% by weight titanium. This is about 13 times less than what was actually found at the Chang'e 3 site. Additionally, here is a full globe titanium map from Clementine, the highest titanium on this scale being 10%, which is about the same as the high titanium Apollo 11 samples. If we superimpose a landing site map over the top of this image, we find that the Chang'e 3 site again corresponds to a region of low titanium according to the Clementine map. And again, as we previously saw, the X-ray spectrometer detected titanium oxide to be as high as 40% by weight. So, no! The very high titanium in the Chang'e 3 soil was not expected and certainly wasn't detected in advance by Clementine. If anything, the Chang'e 3 data proves the Clementine data to be, at best, wrong, and at worst, fabricated. The latter of which I had suspected all along.